In this lesson, we're going to learn about powers and exponents. We will learn how to evaluate an exponential expression as well as how to write a repeated multiplication expression as a power. First of all, let's talk about the components of a power. We have the base in this example, which is 8, and this is the number being multiplied, and our exponent 2 tells us how many times we're going to multiply that base of 8. People can read this expression as 8 raised to the second power, or you could say 8 squared. Now, to evaluate, which means to get a value, you need to write this out. Remember, it is repeated multiplication. So we're going to write 8 times 8, and we get 64. So we can see that 8 squared is 64. Okay, let's think about this. What do you think is one of the most common mistakes made when evaluating exponents? Many times, folks want to say 2 times 4, which is 8. But we know that 2 to the 4th, it is not 8. So what can you do to ensure that you don't make this common mistake? Well, just like in the previous slide, we need to expand our factor of 2. We have 4 2's being multiplied. So when we expand it, now we can go and multiply 2 at a time. We have 2 times 2 is 4. We have another 2 times 2 is 4. And now 4 times 4 equals 16. So 2 to the 4th is 16. Okay, let's do look at the pattern of what's really going on with exponents. 2 to the 1st, so we have 1, 2. Let's change this color here. 2 to the 1st is 2. We have 1, 2. So we end up with 2. 2 squared says 2 times 2, which is 4. Then we have another 2 being multiplied. We have 3 2's. And this is going to be 4 times 2, which is 8. Then we have 4 2's. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we take that previous product and multiply it by the base of 2. Now we have 5 2's being multiplied. So don't look at this as 10. This is not 10. When we have exponents, our numbers increase exponentially. So we have 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 6 times 2 is 32. So the pattern is being every product is being multiplied by that base of 2 to increase. Okay, let's look at one more pattern. We have 3 to the 1st. So 3 to the 1st is 3. 3 squared says we have 2 3's being multiplied, which gives us 9. Then we have 3 3's being multiplied. So we have 9 times 3, which is 27. Then we have 4 3's being multiplied. So sometimes when I compare up the numbers, I will. So 3 times 3 is 9, and we have another 9. So that gives us 81. And now we have 3 to the 5th. Now this reminds me, okay, we're not using calculators in this unit. So I want to say 81 times 3 is 243. So our pattern here, as we increase, is we are just multiplying by our base of 3 each time. Okay, pause the video, write these in your notebook, and you try these. When we come back together, we'll go over these. Okay, 5 to the 3rd is 5 times 5 times 5. So we have 25 times 5, which gives us 125. Number 2, we have the power of 10. And when we multiply this out, we know that we're going to have 1, 2, 3, 4, 5 zeros. So we have 1, 2, 3, so 100,000. 4 to the 4th, again, not 16. We're going to expand. 4 times 4 is 16. We have another 4 times 4. 16 times 16 is 256. And on number 4, notice that we have parentheses. So both the 2 and the 3, the 2/3 is the base. So we're going to expand 2/3 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, over 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, here's where you need to be very careful and make sure you get this in your notes. We're going to compare two expressions that look very similar, but they're very different. In this expression, I'm going to read it as negative 3 to the 4th. In this expression, I'm going to read it as negative 3 to the 4th. In this expression, the negative is not included with a base. This 4, this exponent, is only attached to this 3. So this negative acts as a negative 1. So we have negative, and now we're going to expand just the 3. And we get negative 81. In this case, the 4 is attached to both the 3 and the negative. Our base is negative 3. So we're going to expand the negative 3 and not just the 3. This time we're going to get a positive times another positive. So we get positive 81. So you can see the difference. Parentheses is super important. Okay, so let's try these. Remember, when you have parentheses, the exponent is attached to both the number and your negative, or it could be a variable. So we're going to have negative 2 times negative 2 times negative 2 times negative 2. We're going to get positive 4 times positive 4, and we get a positive 16. Here, the 3 is attached to the 3 and the negative. Our base is negative 3, so we're going to expand the negative with the 3. It is included. This gives us positive 9 times a negative 3, which gives me negative 27. Our last example, the 2 is attached to both the 5 and the negative, so we are going to expand the negative and the 5, so we get a positive 25. Now we're going to look at these. They look similar to the previous ones, but our exponent is only attached to these bases of 2, 3, and 5. So we have negative, and then we have 2 times 2 times 2 times 2. So we get negative 16. Then we have negative 3 times 3 times 3, and we get negative 27. And then lastly, we have negative 5 times 5, which gives me negative 25. So let's notice the difference between when we use parentheses and when we use no parentheses. Let's start with no parentheses. When you have no parentheses and you have this understood negative 1, you can see that all your results are negative. Over here with parentheses, it depends on whether your exponent is odd or even. When we have an even exponent, we get a positive. So when we have, when the exponent is even, we get a positive answer. However, and this is when you're using parentheses, when the exponent is odd, we get a negative result. But you don't have to memorize this, just expand it. Okay, let's move on. And if you want to pause and write those notes down, please do so. Okay, now I do want you to pause the video, and then when we come back, we will go over these together. Okay, so we have parentheses, whoops, I don't need that parentheses, times negative 6 times negative 6. So we get a positive 36 times a negative 6. So no, I'm going to get a negative, and we're going to multiply this out to 16, negative. Then we have negative, and then 10 times 10 times 10 times 10. So we know we have a negative answer because we have no parentheses, and then we have 4 zeros. Number 3, the negative is not included, so we get negative 49. And number 4, we have a negative 5 as our base, so 4 is attached to both the negative and the 5. Okay, so I get negative 5 times negative 5 is positive, and another pair, so I'm going to get a positive 625. Okay, now let's take a look at how you can write expressions as exponents. So the main important thing is to make sure that you know when to use parentheses and when you don't have to. So here we have 3 3's, so 3 to the third, times x squared. Very simple. On this one, we are going to need parentheses if we write it a certain way. So we have 2y 4 times. So we're going to say 2y to the fourth. If you say 2y to the fourth like this with no parentheses, it's as though you were writing, we just have 1, 2, because this 2 has an understood exponent of 1, but we really have 4. So make sure you use parentheses. Or if you did want to break it apart, you could say 2 to the fourth times y to the fourth. Either one of these is correct. The next one, make sure you include the negative. So it's negative 8 with parentheses to the third. It is not negative 8 to the third. Okay. On our fourth one, the negative is not included. And so we have 7 to the 1, 2, 3, 4, 5, 6 power. No parentheses needed here. Okay, pause the video. You try these. When we come back, we'll go from them together. Okay, on number 1, there's a couple of ways we can write it because we have 3 5's and 3 A's. So you could say 5 to the third times a to the third. Or you could group it together and say 5a to the third because multiplication is commutative. You can write it in this order or this order. Number 2, the same way. You can write 4m parentheses to the fourth, or you can write it 4 to the fourth times m to the fourth. What we can't do is say 4m to the fourth with no parentheses. You can't write this. You either need parentheses or put a 4 here. Number 3, we have a negative that will not be included. Again, we have a couple of ways we can write this. We can say negative 9 to the third times c to the third, or negative 9c to the third. What you can't do is say negative 9c to the third. You will either need to put the 3 here or use parentheses. Okay, and number 4, the negative is included, so we're going to say negative 2 to the fourth, making sure you use parentheses. Number 5, we're dealing with fractions, so remember the 1/2, the whole factor is your base, so we will need parentheses for this. So we have 3 1/2 and 3 k's being multiplied. We can say 1/2 times k, all raised to the third, which is how I would write it, or 1/2 to the third times k to the third. Either way you write it, make sure that the fraction does have parentheses. And number 6, the negative is not included. So we're going to say negative 2 thirds to the fourth. You do need parentheses around your fraction.